In the previous video, we derived the mirror equation. The mirror equation gives the relation between three things. And what are these three things? U is the object's distance from the mirror, V is the image's distance from the mirror, and F is the focal length, which is the distance between the pole and the principal focus. I also told you that the mirror equation does not depend on the position of the object. It is the same no matter where the object is kept. Also, it will be the same if instead of a concave mirror, we use some other mirror, say a plane or a convex mirror. As you can clearly see, all the three variables in the equation represent various distances. Now, how do we measure these distances? As I told you that this is a general formula. It means that it's valid for all types of spherical mirrors. But it's only valid for all spherical mirrors if certain rules are being followed. We can't use this formula if these rules are not followed. These rules are also referred to as sign conventions, called the new Cartesian sign convention. And what are those rules? Firstly, all the distances parallel to the principal axis should be measured from the pole of the mirror. All the distances U, V and F are measured from the pole of the mirror and not from any other part of the mirror. And the segment that is used to measure the distance should always be parallel to the principal axis. The second rule is that the object is always placed on the left of the mirror. The rays of light emerging from the object should always travel from left to right. The third rule is that all the distances measured to the right of the mirror are taken to be positive, and the distances measured to the left of the mirror are taken as negative. For instance, we know that when the object behind the center of curvature of a concave mirror, then the image is also formed on the same side. Both the object and the image are on the left of the mirror. Hence, both their distances from the pole are taken as negative. What about the focal length? Will it be positive or negative? The principal focus is also on the left. Hence, it will also be negative. And based on the second rule, we always keep object on the left of the mirror. Hence, this implies that the distance U will always be negative. What if instead of a concave mirror here, we take a convex mirror and keep that object at a finite distance to the left of it? In this case, we know that the image will be formed here. It is a virtual image. The object distance will always be negative. But since here the image is on the right, its distance V will be positive. What about the focal length? For a convex mirror, the principal focus lies to the right of the mirror. Hence, the focal length is also positive. Say the principal focus is 5 cm away from the mirror and the object is kept 15 cm away. What will be the values of U and F? We need to be careful with the signs. Since we know that U is negative, we will take U as negative 15 cm. And F is positive, so we will put its value in the formula as it is. Now we can use the formula to calculate V. If we solve this, we will get V as 3.75 centimeters. Note that the answer is positive value. So the virtual image is formed at a distance of 3.75 centimeters to the right of the mirror. Now what will happen if I don't follow sign conventions? What if I substitute positive values of U and F? In that case, I will get the image distance V as 7.50 centimeters. Which one is correct then? This one or this one? Well, obviously, this one is correct because all the sign conventions are being followed here. There's another way to tell that this is incorrect. We know from our previous videos that the maximum distance of the image from the convex mirror is the focal length. This means that the image of a convex mirror cannot be formed behind the principal focus. The maximum distance at which this image can be formed is focal length, and that is when the object is at infinity. So here, V cannot be 7.5 centimeters. And this value is greater than the focal length, which is 5 centimeters. Okay, this was all about the third rule. There is one final rule which is left. It says that all distances measured perpendicular to and above the principal axis are taken as positive, and distances measured perpendicular to and below the principal axis are taken as negative. above positive and below negative. So if we were to consider heights of the object and the image, both these distances from the axis are above the principal axis. Hence, they are taken as positive heights. Now, if this was a concave mirror and if the object was placed between C and F, then the object's height will be considered as positive, while its image's height will be considered negative as it's inverted. That's it. These were the 4 rules that we have to keep in mind. In order to use this mirror equation for any mirror, we must make sure that all these rules are being followed. In the next video, we will solve a few examples based on this equation.